Hey everybody, this is Chemistry Unit 3. We're going to be discussing most of the things that have been covered in class these last few weeks before the upcoming quiz. So first we're going to start with some key terms. Z effective is the effective nuclear charge. It's a net positive charge experienced by an electron in an atom. It's the actual nuclear charge, Z, minus the shielding from the inner electrons if you want to calculate it. So the number of protons minus the amount of inner electrons equals Z effective. And basically, Z effective means that the outer valence electrons are pulled towards the nucleus, but inner electrons shield them from some of the nuclear pull. So, yeah, that's what Z effective essentially is. Remember that ENC is the exact same thing as Z effective, so these two vocabulary words are interchangeable. You might see one or the other on the test. Just make sure you know they're the exact same thing. Ionization energy. It's basically the energy required to remove one electron from a neutral atom in the gas phase. Right here is the formula for what it would look like to remove an electron from an atom. I will discuss that later, so don't worry about it now. And basically, it just measures how strongly the nucleus holds onto its outermost electron. Next, we have atomic size, which is the exact same thing as atomic radius. So this definition over here is a little wordy. I got it from the slides from Classroom, but basically it's just how big an atom is, the distance from the inner protons or the nucleus to the outermost electrons. Now we have electronegativity. It's basically the tendency of an atom to attract electrons in a chemical bond. Electron negativity increases all the way up to fluorine. So on the periodic table, fluorine has the highest electron negativity, and basically everything just increases to fluorine. So now we know what these definitions are, what these vocabulary words mean. So we need to see the trends in the periodic table with them. So I would take a screenshot of this chart. It's very important. Make sure you memorize it because it's very important for the upcoming quiz and the future of our chemistry units in general. You need to understand what exactly is going on in the periodic table. So here we have Z effective. It increases across a period and slightly decreases down a group. It increases across a period because protons increase, but shielding remains the same. Down a group, shielding increases faster than the nuclear charge, which is why it decreases down a group. Now we have atomic size. It decreases across a period and increases down a group. This is because there's a stronger pull, stronger Z effective, and which results in smaller atoms. More shells down the group, the increase in shells down a group, which results in bigger atoms. Now we have ionization energy. It increases across a period and decreases down a group. This is because smaller atoms hold electrons tighter across a period. Larger atoms, outer electrons are farther away and easier to remove down a group. Electron negativity. It increases across a period and decreases down a group. This may not always be the case because electron negativity increases towards fluorine, so even though I put increases and decreases, this might not be completely reliable. Just know that fluorine has the highest electron negativity, and every atom or every element electron negativity increases towards fluorine. So now we have shielding. It remains constant across a period and it increases down a group. This is because there's the same number of core electrons across a period, but more shells down a group. Again, this is very important information. This describes most of the trends that occur in the periodic table. This is going to help you with the quiz, the test, and all of the future chemistry units. So essentially, in this picture, we can see everything that's going on. Atomic radius decreases down a group. It increases across, decreases down a group. It decreases down a period. Ionization energy increases across a period. Don't mind electron affinity. I'm not sure if all the classes have covered this at all, so ignore electron affinity, non-metallic character, and metallic character. This is pretty straightforward, even though we may not have discussed this in class, even discovered this in class yet. You can take a look at it. It might be useful. And ionization energy decreases down a group, increases up the group. So essentially, this is what we described in the previous chart. This obviously has a little more detail. I just tried to find the best image that basically showed everything that I stated over here in the chart. So now we're moving on to ions. An ion is an atom or group of atoms that has lost or gained electrons, giving it a net charge. Again, I found this vocabulary definition on the slideshow given by the chemistry teachers in classroom. It's a little wordy, but I'm sure you guys get the point. A cation is a positive ion. It basically means an atom loses electrons, fewer electrons than protons. An example, sodium, when it loses an electron, it becomes a +1 cation, plus E minus plus the electron. So essentially, this is the formula. Again, I'm going to go over it in a couple slides, but it's pretty straightforward. I hope I did a good job, briefly explaining it right here. And an anion is a negative ion. It's an atom that gains electrons, more electrons than protons. An example, chlorine, +1 electron becomes chlorine minus. So essentially, groups 1 to 3 will form a positive ion, a cation. Group 1, positive ion. Group 2, positive 2 ion. Group 3, positive 3 ion. Groups 5 to 8 will form a negative ion, an anion. Group 5, -3 ion. Group 6, -2 ion. And group 7, -1 ion. So the notation for ions and formation notation, I just called this over here formation notation because that's, it rhymes, it's kind of catchy. Maybe you guys will remember it easier that way. But first, notation for ions. It's the element symbol with the charge, which looks like an exponent. So sodium ion +1, lost 1 electron, +1 charge. And here we have formation notation. Basically, our example over here is when an atom loses an electron. We have sodium. It's going to become a cation, +1, plus the electron that it lost. So here we have Coulomb's law. This is also very important when it comes to writing explanations for the upcoming quiz. I got this directly from the slideshow given to us by the chemistry teachers. It's a bit wordy, so I did simplify it for you all. So opposites attract, likes repel. Electrons are attracted to the positive nucleus and repel each other. Force is proportional to Q1 times Q2, where Q1 is the nuclear charge and Q2 is the charge of an electron. And force is proportional to 1 over radius squared. It's weaker as distance increases. And finally, outer electrons feel less pull from the nucleus. So if you were to write an explanation for anything on the upcoming quiz, you will probably be mentioning something about the Coulomb's law. You're going to have to include anything from over here to support your answer on the upcoming quiz. So basically, you need to know this. You need to know all of the points that he made in his law. Thank you guys so much for watching. I hope you do well in the upcoming quiz. Don't forget to subscribe. 150 subscribers, and I think I'll do some MA2 videos. 100 is still the first milestone. I only need 4 more to go until I reach 100, and then 50 more to go, and I'll do MA2. Don't forget that I do have my physics honors videos posted to my YouTube. So if you know anybody that is currently enrolled in physics honors, don't forget to let them know that I do videos for them. Probably some of the freshmen in our school at the moment. So please help me advertise, and thank you so much. Thank you so